Okay, good evening everyone. Hope you all can hear me.
Yes,
yeah, we can hear you.
We can hear.
We are about to begin the third guest lecture of the annual lecture series organized by the Astronomical Society of University of Peradeniya. As you all know, today's lecture is on Mars exploration, which will be conducted by our guest speaker, Mr. Janaka Adassuriya, who is a senior research scientist at Arthur C. Clarke Institute for Modern Technologies. So, starting up with proceedings, it's my pleasure to welcome you all on this event. First and foremost, I warmly welcome our guest speaker, Mr. Janaka Adassuriya, Senior Research Scientist at Arthur C. Clarke Institute for Modern Technologies. On behalf of the Astronomical Society, we would like to appreciate your presence here despite your busy schedule. Next, I would like to welcome Head of the Department of Physics, Dr. V. Sivakumar, and the Senior Treasurer of the Astronomical Society, Dr. T.P. Ranavaka. Your guidance and support were really valuable to us in organizing this event. Also, I would like to welcome the former Head of the Department, Dr. V. A. Senaviratna, and all the lecturers from Department of Physics, lecturers from the other departments, demonstrators, and all the undergraduates from the University of Peradeniya who are participating in this event. Last but not least, I welcome all participants from other universities, schools who are gathered here for this lecture. So, moving on to today's topic, Mars exploration. It's a prominent topic on the field of astronomy. As Mars is one of the closest planets to the Earth, astronomers were curious about the structure, the conditions, evidence for life, evidence for water in Mars. Starting from Mariner 4, many space missions were carried out to explore planet Mars. Many information were gathered through them. Recently, the SpaceX, the private space transportation company, also have joined to the race of Mars exploration. So it's quite evident that Mars exploration will be the massive topic in the near future. Further, without due, I would like to invite our guest speaker, Mr. Janaka Adassuriya, to conduct his talk on Mars exploration. Sir, the platform is for now you.
Yes, thank you, Hasita. It's a very good warm evening for you. So, good afternoon to everybody. And so, as usual, I'm going to deliver another presentation for you. This is the third presentation in our series. So it is a pleasure to have some sort of a collaboration with the Astronomical Society of University of Peradeniya in such a nice events organizing in this kind of this subject area, because you know that the astronomy is still now we have actually come to some sort of a level in Sri Lanka, but we have to go very far. So this is just a beginning, and we have started, however, doing the research in Sri Lanka, research in astronomy in Sri Lanka, basically. Now earlier we had this astronomy as a, like a, it's like a hobby, and then just to see the sky and all these things. But now from 10 to 20 years back, now almost 15 years back, we have started about doing research in astronomy. So it is today actually it came to us some sort of a very good position in Sri Lanka also, because even among us university students, especially school students and university students, they are really interested about doing research in astronomy. I have seen this one in past few years, so that is a good sign in the development of astronomy in Sri Lanka. So now in this series also, just now this kind of activity is actually just enhancing their I mean, enhancing the possibilities, the opportunities to join them to numerous activities in astronomy, research, or maybe even promotional programs. Even it's encouraging for them. So in that way, I thank the Astronomical Society of Peradeniya just to organize such a nice event here. So let me start today's presentation. So today I hope to discuss about some this is a part of our solar system. Actually, it's a Mars exploration. Now we have several planets, but we just why we actually just interest about to look at Mars only. So that is also we have to just discuss here briefly why we are only interested about Mars very much. Of course, there are some other planets available in solar system. So let me share the presentation slides with you. Okay, so it's okay, sorry. Okay, so now the Mars exploration, hope of another planet. Now this is just a picture showing that the entire solar system. There are different type of planets you can see here. So when we look at the solar system, there are 8 planets at the moment. The first 4 planets are terrestrial planets. They are solid objects, solid bodies, up to Mars, Mercury, Venus, Earth, Mars. Those are 4 solid objects, terrestrial planets. Then after that, now we have Jupiter, Saturn, Uranus, Neptune. They are gas giants. So that is the structure, basically, the planetary members in our solar system. So then, if you, I just go briefly about the solar system also, just to get some sort of a the first step about to discuss about the Mars exploration. First of all, I will just give some idea about the solar system and why we are looking at Mars only. So that's the important thing I'm going to discuss at the moment. So here, if you look at the content of the solar system, even basically it is the sun, right? And then we have 8 planets, right? And there are some other objects which are belongs to our solar system, like asteroid belt. That means asteroids in the asteroid belt. So they are members of our solar system as well. Then the dwarf planets. Now we have a different category, a new category called dwarf planet, because the Pluto is no longer a planet. Now they are introduced another family member to our solar system called dwarf planets. And then the comets, asteroids, they are also members of our solar system. So that is basically the content. Now, if you look at the percentage of our solar system, so it is mainly sun. So it's nothing else. It's mainly sun. 99% 85 is the sun. And then even all the other planets just taken together, even that is not even 1% of our solar system. So that is basically Sorry. I think I just mute my mic. Is that?
Yeah.
Sorry, I did not realize that. So I muted my mic at the beginning. So shall I go from the beginning, right?
Yeah, maybe the second slide. Yeah,
The second slide, okay.
yeah.
So something wrong with that. Okay, so I think this is the content, the solar system, right? And I hope you can hear me. Yeah, that's
Yeah, we can hear you.
yeah,
No problem.
sure. So if you look at the content of the solar system, uh, the apart from 8 planets, so we have some other objects in the solar system like asteroid belt, then the dwarf planets, comets, and then the asteroids coming from other parts of the solar system. So they are also members of the solar system right now. Now, if you look at the percentage even, now the percentage even, it is almost sun, it's nothing else. So it is 99.85%. And even all the other planets, it's not getting a 1% even, it is less than 1%. So this is the percentage of the mass percentage of the solar system. And if you look at the structure, basically the plane, the orbital plane of these planets, how they align to each other. Uh, if you look at the Mercury has the inclined plane to the other respect to the other planets, like 7 degrees inclined to the other planets. And Pluto, it's no longer a planet, but it is a dwarf planet right now. The Pluto has also a very much inclined plane of 17.2 degrees angle. So other than that, all the other planets are almost in the same plane, we consider all of them are moving the same plane. So this is the structure, the orbital structure of the solar system. And if you look at the individual planet, the tilt of the axial tilt of the individual planet, axial tilt. So if you look at the axial tilt of the individual planet to the orbital plane, Mercury almost perpendicular, Venus it is 177 degree. That means it's a meaning of that it is upside down. Uh, the planet is upside down. So that kind of idea we can get it from there. Then Earth is 23.5, Mars is 25.2 actually. So almost same these two planets. Jupiter 3, almost perpendicular. Saturn 27. Uranus is again unusual arrangement. It is 98 degrees, almost the axial rotation axis is parallel to the orbital plane. So then it is very interesting. So if you look at the day-night feature, day-night change in Uranus, you don't see a day-night effect here. So one pole is always in night side and the other pole is always in the day side. So it is very interesting if some, the life is there. So it's actually experiencing that daytime and nighttime. And if you want to sleep, then you have to go across the equator and then go to the other side. So get the night. So the Neptune is 30 like that. And so this is the axial tilt. And the Venus and Uranus rotate opposite to the other planets. That means east to west. Now, you know that the Earth and other planets, they are rotating around themselves from west to east. But Venus and Uranus are also different members, so they are moving from east to west, the rotation around themselves, right? So from east to west, that means the sunrise is actually from west, sunset is from east. So that is the experience over there. Uh, Then I just want to give some idea about the Earth, because we are going to compare about the Earth and Mars, why it is important, the Mars exploration. Let's look at the Earth. These are the, the statistics of the Earth, but we almost actually know about all these parameters. So it's very familiar for us. So I'll just move into that. Next slide. Of course, this is the best place to live it, right? If you look at from the space, so this is the best thing, the best object in the solar system or even in the universe at the moment, because we don't know other places such a nice environment to live. So this is the only place at the moment. So space, if you can see the blue, even green also, vegetation you can see here, right? So it's everything, the oceans, the clouds, atmosphere, thick atmosphere, all of these are actually supporting the life uh, evolved here in the Earth system. This is how the Earth actually evolves, right? So I just took it from the Sky and Telescope magazine. The Earth has actually passed a difficult time, right? So that difficult time means the Earth at the today uh, cannot see the slides. What's wrong today? Mm, can you see the slides? Is something wrong?
We can see actually. I mean, I don't know, Dr. Varuni. I mean, is there a problem with you?
Yeah, maybe then it must be me. I'm using my phone and
Okay, so
Yet
can you see now?
Yeah,
what?
we can see. Yeah.
Okay, I'll check then. It must be something wrong with this.
Okay,
the device only.
yeah, right. I hope that everybody can see now. Here, this is the artistic impression of how the Earth evolves to the today's condition up to today. Now it has actually passed a very difficult times, like there are a lot of disturbances in the Earth system, and then it is not going to be really a friendly environment earlier. So very much earlier, like 3 to 4 billion years ago. So if you look at it like earlier, now we believe that the Earth system is also like it is a one continent. Now we have 7 continents, right? But earlier it has one continent. All these actually land area is actually just as one continent. Right now we have all these continents now separated very much. So like the North America, South America, Africa, and Australia, and all these things. So this is how does it, how was it that earlier, 350 million years ago, one continent, and then 65 million years ago, slowly this just apart from each other. And then all these continents actually created right now separately. We have identified everything very clearly. So then we have passed several eras. Then these eras actually just identified as this is the first era where the solar system actually began here, like 4.5 to 3.8 billion years ago. That's called the Hayden era. So in this Hayden era, so the Earth system is quite actually different, and there's no hope of life. There's no way of life formed here. So it is a very just difficult time for the Earth. That means there are a lot of the meteorites actually strike on the Earth, and there are a lot of volcanic activities going on, and it's going to be like a very dynamic planet. And then the system is still actually just forming. The time is actually the system, the formation happens. So that is 4.5 to 3.8 billion years ago. So then after that, like 3.8 to 2.5 billion years ago, called Archean era. Now slowly what happened, the sun start actually just get shining brighter than earlier. So the sun actually gets brighter and brighter. So it is come to some sort of a steady state, like a equilibrium state of its luminosity, like 85%. Now it is 85%. So therefore, the system actually gets little bit, the entire system, the solar system actually get little bit formations, and then the system get little bit in a ordered way, and then slowly settle down. So this is like a protozoic era, 2.5 to 6 billion years ago. So this is actually what we call the life spread onto the earth. Actually, the early era, the primitive photosynthetic life appeared in 3 billion years ago. So inside the sea, right? Now here, the development of oxygen and all in the atmosphere, the life spread onto the land. So this is what happens in this era, 2.5 to 0.6 billion years ago. Now this is how the Earth system actually evolved, right? And I just move into the mass, the planet Mars. So here we have the very thick atmosphere in Earth system. The atmosphere actually just divided into few parts, like troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So these are the atmospheric structure in the Earth system. We have a very thick atmosphere. Now, this is the basically the idea what we have in Earth system, right? So the Earth system is very much supportive to the life, and then we know that how much is actually just supporting, and it is actually continuing that the system in the steady state right now. So even that, if you look at the greenhouse effect, now we are in the right greenhouse effect, right rate of greenhouse effect, rate basically. Now the rate means the greenhouse effect actually produce the temperature, the warmth of the entire planet. So that is exactly a right temperature. Right temperature means the mild temperature to us to live it comfortably. Like the Earth system has a temperature of, average temperature of 18 degrees Celsius. Average temperature of the Earth is 18 degrees Celsius. So therefore, it is a friendly temperature, like it is a very comfortable temperature for us. So we don't have any problem with that living. So then the greenhouse effect is going on in the Earth, the right rate, right? So that will produce always keeping the 18 degrees Celsius throughout the atmosphere, throughout the Earth system, irrespective of day and night even, right? But this is not this is not happening. I mean, this kind of thing that if you look at the other two planets, like basically Venus and Mars, right? So the Venus and Mars are on the other two sides, either side of the Earth, close to the Sun, Venus, and away from the Sun, Mars. So they are also experiencing the greenhouse effect at the moment. The problem is the greenhouse effect of Venus is very much, and therefore the temperature is also very high, that is up to 470 degrees Celsius. 470 degrees Celsius, the Venus in atmosphere. So it is throughout the Venus, 470 degrees Celsius is there. So therefore we cannot think about, or even we cannot think about the existence of any life over there. Now what happens to Mars? What are the conditions on Mars? So here, these are the orbital, some of the basic parameters of the Mars. Orbital period, 1 year is 1.88 Earth years. Mars is exactly, this is a small planet, comparatively small planet, smaller than Venus even. So it is 0.11 Earth mass, exactly half of the radius of the Earth, that is a half-sized planet of Earth, and then the density, velocity, escape velocity, and the rotation period is 24.6 hours. So this again exactly similar to Earth system. And somebody can actually then think about that this is the best thing. Of course, this is the best place apart from the Earth, right? This is the best place. We some sort of a similar characteristics are there in the Mars system. And there are axial tilt also, it is 24. There are two moons, but they are not a very big moons. They are small moons, like a few kilometers wide. Now, if you look at Mars system, I mean, people observed this one for a long time, and they have given the name like Mars. What is the meaning of Mars? Mars is the god of war, god of war. So it's just given these the names of the goddess and the gods for these planets. Basically, Venus is the beauty of goddess, right? And Mars is the god of war. So why the people actually given this name? Because they have seen this planet in red color in the sky. They have identified always in a reddish color. So maybe people think about that there are a lot of actually wars going on, and the bloodshed always there in the planet, and kind of impression is that, and they give the name the red planet and the god of war. And these two images exactly images of Mars taken from a very long time back, this image, and this one is later. People thought about that the Mars has some sort of a civilization. Even they thought about the civilization even higher than the Earth system also. They are very highly civilized, the aliens kind of, or maybe a kind of people living over there. Aliens are there, and they are maybe intelligent than us. So these are the thoughts of the early people, and even these images supported that. Now, if you look at this image, right, they have taken this image from a very low resolution, not very high tech telescopes, right, and they have observed and look at it. This is like a face, right? You can see two eyes, and then the nose, and maybe the nose and the mouth and all. So then maybe imagine that there's some sort of a face, and it's looking at us. So these are the thoughts they had it earlier. And there are a lot of images like that early, they have taken in early pictures of the Mars system. And now we know that the same area we have photographed it with the high resolution cameras, telescope, powerful telescope, and it is nothing else. It is a geological feature. It's nothing else. So this kind of imagination we had it earlier. Based on that, maybe you have also seen this movie, War of the World, right? The War of the World is a movie. Basically, it's just giving some idea that the Martians, that means the people or the aliens coming from planet Mars and then invaded the Earth, right? Kind of idea. And this is a book actually, The War of the World. It is written by H.G. Wells in 1898. So based on this book, we had this film also called The War of the World, right? So there are several films actually made based on this. So we had this idea earlier. Now we know that at the moment now we identify this planet very much, and we already know that there are no very high civilization, intelligent civilization over there. But we have to investigate further and further to see whether any form of life is there in Mars system. So then we have taken these images of Mars in 1995, 1997, 1999, like that. And then these features also you can see very clearly. What is the importance of this image is that this planet is actually just getting closer to us and sometimes getting away from us. So when it is getting closer to us, uh, we had one very close encounter in 2003, August 2003. So when was that happened? So the image taken from the Hubble Space Telescope is something look like this. All these are actually taken from Hubble Space Telescope in different times. So the uh, the uh, the angular size, apparent size is, you can see even it's getting bigger and bigger. In 2003, the biggest, and again 2005 is again getting small. So this is what we call mass closest encounter. This is like a 50 years time. I mean, the next one actually comes again after 50 years. So it is also a kind of a lifetime event. So we don't have, we have to get these opportunities all the time, because these astronomical phenomena, some of the astronomical events are lifetime events. Now, I think you have seen that last month, December, we had such an event called uh, Jupiter Saturn conjunction, the Great Conjunction. That was also very rare event. So it came after 400 years to that much of closeness. So this kind of activities are very interesting, and even they are lifetime events. So if you miss it and you don't get it within your lifetime. So this is another event. And if you look at Mars, this is the close encounters. Now you can see even the very close pictures with all the geological features you can identify. This is a kind of a color, is a red color planet. It is because of that it content, the soil content is mostly the iron rich content. So therefore that is kind of a red color. And if you look at this one, even now, see, there are a lot of geological features, right? Even you can identify from the small telescope, even there are a lot of geological features. It is actually very much rich of geological features like mountains, valleys, and all these things are there in the Mars system. So then, if you look at these features, we can identify them. These three are volcanoes, right? These three are volcanoes. And then this is called the Rift Valley, or even Valles Marinaris. That is another name given for that. This is a Valles Marinaris, even identified from space-based telescope. Even from the ground-based telescope also we can see this. So this is called Rift Valley also. It's a huge valley. You can see this actually just going across the entire planet, right? So it's going across the entire planet. And then there are volcanoes also appear in this image. Actually, I have this video on this uh, Rift Valley. I think it is worth to see. Actually, this Rift Valley is completely covered by the mission orbiter going around the Mars. So now they have get the entire landscape, or that means a terrain, entire terrain. They have actually mapped it, and then they just produce this video. How does it look like, right? So I will just run this video for you. I will just for a moment stop the sharing. Okay. Okay, I think you can see the video presentation. Can you see?
3,000 miles from New York City to Los Angeles, and it's nearly as deep.
Can you see the video?
The grandest canyon of all.
Yes, sir.
Yeah, we can see this.
It's on the
Yes, we
planet
can
Mars,
see.
Valles Marineris, or Mariner Valley. This canyon is so long it could stretch 3,000 miles from New York City to Los Angeles, and it's nearly as deep as Mount Everest is high. Lifting off in a cloud of dust, our scout ship heads for Mariner Valley. A swarm of tornado-like dust devils whirls across the mesa, just as in the deserts on Earth. Dodging them, we pass impact craters, where large meteorites violently struck long ago. Dead ahead in our race toward the rim, winds are blowing dust clouds up the valley slopes. Mariner Valley is 10 times longer, 5 times deeper, and 20 times wider than Earth's Grand Canyon. You could drop the entire Los Angeles basin inside with room to spare. The rim stands almost as high above the valley floor as Mount Everest on Earth. Looking westward all along the valley's length, we find giant landslides that tumbled off its steep, rugged walls. On the left lie numerous rocky spurs and narrow gullies formed by slumps and avalanches. After crossing a low ridge, we fly up a tributary side canyon. Inside, the canyon twists and turns in a stream-like way. Geologists think this side canyon was born as groundwater escaped and the surface collapsed. Several more tributary canyons cut into the valley's rim. These also grew where groundwater undermined the surface. The valley walls run far into the distance. Its cliffs and ridges were born through earthquake faulting, the main geologic force that began to open the valley billions of years ago. Tucked into the valley's widest part, Melas Chasma, are many layers of dust, sediments, and rock. Each records a slice of time and fills a few pages in the geological record. Ahead lies a catastrophic landslide that crashed down 15,000 feet and shot debris nearly 100 miles across the valley floor. Beyond the landslide lies another basin containing more layered deposits. These offer glimpses of the past and record part of the valley's complex geological story. Farther into the basin, the floor is covered by hills made of layered sediments whose origin remains a puzzle. Winds blowing for millions of years sculpted the soft ground into long ridges. Turning up a narrow canyon and sailing over a gullied ridge, we fly into Ophir Chasma and find more sediments, wind-carved ridges, and a steep wall with rock rubble heaped at its foot. A long parade of landslides widened the valley, collapsing walls made of hard volcanic rock. A flight through Mariner Valley gives us an exciting glimpse of its geological complexity. Buried in the rocks of this Grand Canyon of all the planets lies a history book of Mars that scientists have just begun to open. One day, perhaps soon, we'll read the full story of this beautiful and spectacular place.
Yes. Okay, so come back to the slides. Right, so that is kind of the movie that have created by just taking the exact the radar map of this Rift Valley or Valles Mariner by the orbiter of the mass, the planet just going around the Mars. So then if you look at these volcanic mountains, so this is called the Olympus Mons, the highest mountain in the solar system. Now you can't believe that even, right? Now Earth is a very big planet and we have a very high geological features, the variations and the geological diversity we have. But although we have these rich geological features, the Mars has the highest mountain in the solar system, Olympus Mons. Now this is the highest mountain. This is 3 times taller than the Mount Everest. So even we can't actually believe that how this small size, half size planet of the Earth actually get this kind of feature. I will come to that the explanation later on. However, we have this kind of variation in Mars. Now I just post this one for you. Now, if you look at these two pictures, uh, one is a planet Mars and the other one is planet Earth. Can you identify what is planet Mars and what is planet Earth? A, B. You can actually just put some your response into your chatting area. What is A? What is B? Yes? Yeah, there is a one answer. Two. A is Mars. B is Earth. A is Mars. A is Earth also counts. Okay. B is Earth. Yes. Yeah. So B is Earth. Yes. So it's B could be Earth. Yes. Right. A is Mars. Yeah. Basically, now if you look at these two pictures, you can actually guess even by looking at carefully. If you look at the sky, then it is very easy to identify. Of course, B is a blue sky you have here. B has a blue sky. So that is obviously planet Earth. And here, this is a dull sky, like a brownish sky. So that is going to be planet Mars. But if I cut it off from here, like just cut it off these two skies from these images, can you exactly identify easily which one is Earth and which one is Mars? Of course, bit difficult, right? So that means if you look at the surface of Mars and the surface of Earth, so we have also some similar areas, or even we can say that there are some similar areas in Mars as well, which are very close to each other, the surface features, right? Now this is a surface of Mars and this is a part of a Libyan desert, right? And of course we have some similarities, right? That is something interesting here also. So the desert kind of exactly the Mars is a kind of a desert, completely covered with the desert, and there's nothing else. So always the Mars is something look like this, the entire planet, and but we have different features. Now, what do you think about this Earth? Of course, I can't see Earth and Mars. If you look at Earth versus Mars, now this is the challenge, right? Now, can we make another home someday for us? Can we make another home? Of course, now we have a lot of threats. At the moment, we are experiencing one threat for the mankind. The pandemics are going on. So it is going to be it can be a worse in the next one. Can be a more worse, I mean, just worse than this even, right? So therefore, we need some sort of a alternative solution someday. If something happened to the Earth, so what we are going to do, right? Where we are going? So that's why people always have this thought in their mind from very much earlier even. So is there any other place whether we can think about to land, or maybe we think about to settle down in some day, right? So when you look at all these aspects, so Mars is a very good place. Mars has some sort of a potential to change to a form of a supporting life, as well as a form of a habitable place to live there. So that's why we are very much interested on Mars. Of course, we have some similarities, but we have a lot of challenges as well. Are they similar or are they completely different? Can Mars change into a habitable world? So that is the question at the moment. And if you are going to change it to a habitable world, what are the challenges we have to take? So that's why we are very much interested on planet Mars. Now, if you look at the planet, the details, right? Interior and exterior. Often the visible as a reddish light in the Earth sky, Mars captured the imagination of those who dream of space travel. The planet thin atmosphere is a hostile to a human life, but Mars has many interesting geological features similar to those on Earth, such as volcanoes and canyons. Right? There are some similarities. Of course, there are some differences which we cannot still deal with the present technology. If you look at the thin atmosphere, so it is a very thin atmosphere. It's a 1% of Earth atmosphere. So you can imagine then that is going to be a really challenge, right? How we are going to live with this much of thin atmosphere. And even this atmosphere is a 95% of carbon dioxide. It's a carbon dioxide rich atmosphere, very thin atmosphere. And if you look at the temperature, now what is the Earth temperature? It is 18 degrees. Now in Mars system, the average temperature is minus 55 degrees Celsius. That is around minus 55 to 60 degrees minus. So then it is not going to be friendly for us, and we cannot think about to live over there with just such a very freezing temperature, low temperature. And the atmospheric pressure is zero point 0.7 of the Earth average Earth pressure, right? So this information about the inside is not really known, but we thought that, we believe that it is something similar to the Earth. It has some sort of a liquid sulfur core, and then we have a solid inner core as well. So the liquid outer core and as well as a solid inner core. And then the mantle and the crust is also there, as which is similar to the Earth. But the important thing here is Earth has a very strong magnetic field, but Mars doesn't. So that is another problem, because we know that we are protected, very much protected from our magnetic field from the solar radiation, and we learned about the solar radiation very much, and how we actually just protected by the very strong Earth's magnetic field. But Mars doesn't have any magnetic field. So therefore, that's another problem. Now, the comparison of the gravity, it is 3.38 of Earth. So if you jump 10 feet, so that is kind of an advantage for us. So if we can lift a rocket over there, so then we can lift it very easily with a very much less fuel than the Earth. This is a sunset actually taken from the Spirit rover in 2005. Of course, you can see the sun here. It's like a moon over here, since it is 1.5 astronomical units away from the sun. And this is the comparison of Earth and Mars. So if you look at the places of these three planets, basically, now we have discovered a lot of planetary systems. That is a completely different presentation. In some other day we can consider it. So there are a lot of planetary systems discovered right now, more than 4,000 planets just moving around other stars. Now, when we look at these planetary systems with the parent star, we can define a habitable zone. Habitable zone. It is depending on the parent star as well as the planets. Basically, it's depending on the parent star, right? This habitable zone. So our habitable zone is to be shown here in the green color region, right? In this green color. So the Venus is in the inner edge of the habitable zone. Earth is exactly at the middle of the habitable zone, the right place exactly. That's why we are here, right? Mars is at the other edge, outer edge of the habitable zone. However, they are almost within the habitable zone. So therefore, we can think about the Mars system is also a considerable place to change it to someday to a habitable world. So because of these interest, people send a lot of missions. Now even NASA, the European Space Agency, and all these the space agencies, they have actually sent a lot of missions to Mars. Uh, they are orbiters as well as rovers, right? At the moment, there are several orbiters moving around the Mars. I don't think the Odysseus now is going on, but that is orbiter. But all the other orbiters actually just moving around the Mars at the moment. Mars Reconnaissance Orbiter, MARVEN, Mars Express, ExoMars Trace Gas Orbiter, Mars Orbiter mission. So these are moving around the Earth, the Mars system. So it's just looking at it and then taking pictures and then looking at it continuously. The observations going on all the way, just to get the information from the Mars system. And then we have rovers, right? The rovers also send it to Mars at the moment. They are Curiosity, Opportunity, Spirit, InSight, Mars 2020 rover. So from these rovers at the moment, Opportunity and Spirit, they are no longer in service. So they have actually finished their lifetime, and they just actually finish, and then there's no way of observing continuously. So those two missions are now died. So only the Curiosity is just operating right now. InSight is not a rover exactly, that is a lander. It is just a landed on the planet. I will come to that, and then just doing some experiment on that place. Mars 2020 rover is on the way to Mars, right? So it is going to be very soon. That is February 18th, February 2021. It's going to land on the Mars. So these are basically the three rovers. You can see the sizes of these three rovers. So this is called Sojourner. That was sent in 1996. You might remember our scientist, the Sri Lankan scientists, also actually just took part of developing a infrared camera. Dr. Sarath Gunapala, you remember that? So he was actually just designed a thermal camera for this rover. And then we have this Opportunity Spirit rover, a little bit bigger than the Sojourner rover, sent in 2004. These two rovers are no longer now working. And then the Curiosity is a kind of a big one. You can see it is a kind of a size of a small car, right? So that is just operating right now. Recently, the Curiosity rover spent 3,000 days in Mars. That's what they announced it just a while ago. So now, if you look at Mars in very in close look at, so the Mars has these two ice caps. Even a very small telescope from the ground-based observation can actually capture these two ice caps. So these two ice caps are very prominent here, and they are there throughout the year of the Mars, or throughout the time, right? It is just getting smaller, but but it is never disappeared, right? It never goes. So it is getting smaller and then getting bigger because the Mars also has the seasonal changes. So these images taken from the top of the polar ice caps from those orbiters. So you can see clearly that is there. And these are the images taken of those ice caps. You can see here, these ice caps are there for throughout the time of the Mars. So then these sizes of this is like a 250 miles across, I think, yes. So this banner is always in the top of that images. I can't actually read the text sometimes. 250 miles across. It consists mainly of frozen carbon dioxide. This is not water, right? It is not water. It is a frozen carbon dioxide, what we call dry ice, right? Dry ice, that means a solid carbon dioxide. It's not water. But underneath this, now they have discovered there are some sort of a water layer. There are some amount of water underneath this area in the ground level. So these are actually real images, right? Taken very close encounters of these ice caps. So the ice actually just stay there throughout the year in this. Now this is the a very good evidence of having having water uh, on Mars actually. So this water is actually under this layer, like the crust, like a 1.5 kilometers deep. They found that there's a water uh, lake, a kind of a water lake. Let's say the water lake, right? So this liquid water is available. That means a liquid water. Liquid water is available in this image. You can see here. This was taken by Mars Express orbiter, uh, 20-kilometer wide underground water lake. That is estimation. It's given by this mission. You know that these missions can actually produce radar. They are called ground penetration radar. Ground penetration radar. That system will just produce this image, the radar image, subsurface image. So then the surface, and then you can see here that the blue color, the different color, just showing that the presence of water, liquid water. But the temperature, they have discovered the temperature is minus 75 degrees Celsius. So how then the water actually just stay in minus 75 degrees Celsius? So we know that there is going to be not water, then it's solid, the ice, but it can. So the meaning is sometimes they might actually express it in or explain in that way. This is not a pure water. This is completely actually mixed with a lot of salt and a lot of other elements actually mixed with that, the compounds, right? Mixed with that. So sodium, magnesium, calcium compounds, the salt, it's a completely a salty water. So then it's an impure water. It can actually just stay with a very low temperature, even in the liquid state. So that is the understanding at the moment. Now, these images show, these images give a very good idea that the Mars actually has, Mars actually had covered some sort of a liquid very much earlier, long time back, right? Mars actually had covered some sort of a liquid, some sort of, maybe water. Basically, they said that is maybe water, but it's kind of a liquid, right? So it should it would have been covered some sort of a liquid like this, right? When you look at these images, so these images even give some sort of an impression that even when you look at in the Earth system also, when something actually happen, like if you go to shore, right? Then the water, when you actually just go back to the sea, so then the remaining, the sand is something look like this, right? You feel the same features like in the, here also. So therefore, then some sort of a liquid was there for a long time back, like maybe 3 to 4 billion years ago, right? So when this type of images they have taken everywhere in the Mars. So when you look at this image, so obviously now we are familiar with this kind of image even. See that? This is a streamline, right? And maybe it dried off. Streamline, maybe a liquid water or maybe some other liquid, maybe dried off after some time, still remaining over there, right? So this is also gives some sort of very strong evidence that the Mars has covered with some sort of a water or liquid or oceans very much earlier. Now this is another one. So this was very familiar for us. Now you go to somewhere in Anuradhapur or Polonnaruwa in the dry season. So you can see the tanks actually when they dry off, right? So you can see this kind of feature from the top, right? And this is another evidence, right? These are called sedimentary rocks, right? Sediments, right? These sediment geological features, sedimentary rocks, formed once this part actually covered with some sort of a liquid for a long time, right? it has covered for a long time by just a liquid. So then these sediments actually form. So these sediments are also there in Mars system. Okay, then we have some sort of a very strong evidence that the Mars has covered with oceans, liquid ocean most probably, right? And then that like a 3 billion to 4 billion years ago. So then the question is, what was happened to this sea or the ocean? What was happened to this ocean? Now, this ice cap, like maybe it's still there, like a 13% of ice cap is there, still there, this one. But they believe that the entire globe, the Mars globe actually covered by the oceans, like 87% of ocean, 3 billion years ago. So you see, this is the kind of impression that 3 billion years ago. So then what was happened to this liquid? What happened to this water, right? So then kind of an explanation we can give it for that. The Mars has a very thin atmosphere. It has a very thin atmosphere, 1% of Earth atmosphere. So then what happens, within this thin atmosphere, the atmospheric pressure is very low. Atmospheric pressure is very low, right? So the low atmospheric pressure, what will happen to the boiling point of water? The boiling point of water drops down to, let's say, like maybe 80 degrees or maybe 70 degrees or maybe 60 degrees, even less than that, with a very low atmospheric pressure. Then the dropping down this boiling point can easily evaporate or boil the water in the oceans, right? So therefore, this will happen, I mean, this is actually happening for a long time. Then slowly, all the water actually vaporized or then boiled it away, and then it is actually went to the atmosphere. Then what happens in the atmosphere? Now, we also have the same scenario in the Earth system. Evaporation takes place, right? Always the evaporation takes place. The boiling means, I mean, it's basically evaporation. The entire sea evaporates very much. And then all these water molecules get into the atmosphere. But fortunately, we are actually having a process that the water actually just take it back to the sea, the system. The cycle is going on, right? So condensation happens, then the rain system we have, the rain, and then we get the same amount of water, or maybe the cycle is always actually going on. So then there's no way of losing the water molecules. So we are getting back to the system. But unfortunately, the Mars system, the problem is when these water molecules get into the atmosphere even very thin, the gravity is also very much low. So then the molecules can actually go to I mean, just rising up to a very high altitudes, right? And then what happens, the solar radiation, then these molecules exposed to the high energy solar radiation, what happens, it break into oxygen and hydrogen. And the hydrogen is even lighter, they just move into the very high altitudes, and sometimes most of the hydrogen can escape to the space, and there's no way of recombining, right? Then whatever the oxygen remaining, so earlier the volcanic activities of the Mars system is very much higher. It will produce a lot of carbon to the atmosphere. This carbon and the oxygen recombine and form the carbon dioxide. So the carbon dioxide formation actually goes on, and the carbon dioxide is a very high greenhouse gas. So therefore the greenhouse effect is also very much, and then it will produce more and more heat, and finally what will happen, all these water quickly boiled away or evaporated very much, and then there's no way of getting it, the cycle has no way of getting it, that there's no cycle, and then completely the oceans slowly lost in the Mars system. The other important thing here, we have the ozone layer, right? So the ozone layer cut off the ultraviolet high energy rays from the sun, ultraviolet radiation, but Mars doesn't have it. So you can imagine that how important our system, right, to sustain the life. So all these other two corners like Venus and Mars, they don't have, these two planets don't have the supporting system of just to maintain the life, or maybe it is not going to be easy to change it even to a habitable planet, right? So that is what happened. Now, if you look at the weather report, now this is called weather report on Mars, near the peak of the summer and near the equator, summer, because it has a seasonal effect, summer season, it is going to be like a 5 to 10 degrees. It's like in Nuwara in Sri Lanka, right? It is even in the summer, right? So the most of the other times, it is going to be, I mean, drastically low temperature. So you can't imagine even it is a frozen like a minus 25 to minus 100 degrees Celsius. So CO2 snow falls onto the surface. The snow is there, but it is CO2, not water. Massive dust storms going on. We have to face these things when we are going to live over there. Radiation burn. There's no atmosphere and there's no ozone layer to protect us. So it is completely exposed to the high energy radiation. And then if you go just outside the Martian surface, and then you might die within few hours because you exactly exposed to the radiation. So even the temperature difference from your feet to your head, it is a drastic change like minus 10 degrees to minus 30 degrees, right? So this kind of experience we can imagine on the Mars system. This is the temperature profile of the Mars system. So you can see the Earth atmosphere, and this is the temperature profile of the troposphere, stratosphere, mesosphere, thermosphere. We have ozone layer in the stratosphere, and this is the temperature profile of the Mars atmosphere. And there's one problem that in the Mars system, I think, yeah, I will show you this one first. When they have taken these pictures, I think it's very much close to each other. This is June 10th June 2001. This is 31st July 2001, just after more than 1 month. What happens to these two pictures, right? What happens to this? So here, it's a very clear atmosphere. You can see the features of all these things very clearly. And just after 1.5 months, what was happened? So it is completely covered by something. You don't see anything here, right? So what was happening here? So there's a global dust storm completely covered the entire Mars, and it has actually blocked all the light or all the features. You don't see any feature over here. So it is completely, these dust storms are not local. They spread out throughout the planet when they are actually occur. So they are called global dust storms. So these dust storms are very strong, and even that is going to be a really problem for us when we are going to live over there, and we have to face these challenges, right? So what is the reason for these dust storms? Now they just give some explain for that also, how the dust storms create on planet Mars. If you look at the Earth system, Earth eccentricity is 0.017. Mars eccentricity is 0.09. I mean, the eccentricity is much bigger than the planet Earth. So therefore, it has some sort of elliptical orbit, the Mars. So that means the Mars actually getting closer to the Sun in a one period, one time, and then it's going away from the Sun in the other time. So these seasonal change is very much, right? So sometimes the Mars actually exposed to the very high solar radiation, and sometimes it has a very weak solar radiation in the winter. So therefore, what happens in the surface of the Mars when the summer season, when the sun is shining on the equator, the temperature is very high compared to the other areas, like in the polar regions. Temperature difference is very high. Like the difference of the solar radiation is 45% difference with the polar regions and the equator. While the difference of the Earth system is that is maximum 7%. This difference of the radiation on the equator and the polar region, what happened, the equator actually, the temperature rises very much and the polar region is very cold, and then there is a pressure difference, very much pressure difference. So you know that if there's a pressure difference, the low pressure areas always, you know that there is a very high winds actually just start blowing it. Also, we also experience these tornadoes, hurricanes and all these things, storms, geostorms and all these things, right? So the similar thing happened, but it is very much stronger than the Earth system. So therefore, it is spread out throughout the globe of Mars. So therefore, the equator heats rapidly and makes a considerable temperature difference with the polar region. This triggers the storm on Mars. So then it is going to be something look like this. I think you have seen that the film called Martian, right? Everybody has seen the Martian film. That is a recent film, 2017 or 16. So this Martian film, they just use this the Mars global dust storms. So that crew, the set of crews actually just working on the Mars, they just experience a very strong dust storm, and then they just leave the planet and then leave behind a one person. Anyway, the rest of the thing is not going to be true. But even that they said that the dust storms are there. That means that there are winds, right? So in that film, actually just show there's a very strong wind, but the fact is that since the atmosphere is very thin, uh, the Mars does not actually experience a very high speed winds, like maybe a 60 kilometers to 70-kilometer wind, like in the Earth system. They just suspect that the winds are not that much of strong because of very thin atmosphere. Okay, so this is a result of these global dust storms. Now, I told you that two rovers are no longer operating right now. Especially the Opportunity rover was a very successful rover. They sent it 2004, and then up to maybe last year, 2019, it was actually working very nicely, giving lot of servicing, giving good results, very important results to us, 15 years of service, and it came to end with these global dust storms. Now you can see here, this is Opportunity, and the solar cells of these Opportunity rovers completely covered by dust, just as a result of dust storm. And they could not actually recover this one. I think a long time actually is covered by these dust, and then that 15 years mean the battery system is also getting weaker, and then they could not wake up this robotic rover, and then now it's completely died and it's no longer working. So it's as a result of these global dust storms in Mars. Okay, now this is a seasonal effect of Mars. Now we have the seasonal effect, like we have 4 seasons, very clear 4 seasons, because of the 23.5-degree tilt. Now Mars also has a 25 degrees tilt, which is similar to us, and definitely in the Mars system also we can experience some seasonal changes. Now, they have divided the Mars system into 4 seasons, right? And even that summer, autumn, the same way, northern summer, northern autumn, northern winter, northern spring, like similar to Earth system. So, but the time of the one season is much bigger like even a few months, right, in Mars system, because the orbit is very much bigger. So this is the explanation, the comparison about the seasonal change in Earth system and the seasonal change in Mars system. This is seasonal change in Los Angeles, right? So this is the temperature change, right? Typical temperature change at the range. And here, this is the Gale crater in Mars. They have measured the temperature change. So it is a drastic change even. So from like a minus 20 degrees to minus 80 degrees Celsius. So that is the temperature difference. Okay, so the problem is now we know that there's a very thin atmosphere of Mars. Then earlier there was that was covered by a completely ocean, and maybe some sort of a thick atmosphere might be there, right? Most probably maybe thick atmosphere than this. So what happens to this atmosphere then? Maybe some sort of a thick atmosphere was there earlier. Then what was happened to this atmosphere, right? How the Mars lost its atmosphere? And these are some sort of explanation. This is called sputtering event, right? The sputtering event means the radiation, the solar radiation actually breaks these the molecules into ions and the electrons, and these ions itself, right? These ions themselves actually trapped with the solar magnetic field and then get accelerated and then knocked with the other atoms, kind of a process, right? So these the ions can actually knock out the other atoms also and completely ionize everything, and then finally what happened, the solar radiation is blow away all these ions from the atmosphere. So this is a one process they explain, that the sputtering process. And then this is called the plasma process also. Even that is similar to that, the radiation actually breaks again these molecules like the carbon dioxide or water molecules into ion and electrons, and then the electrons actually knock out the other the atoms and completely ionize all these atoms, and then finally the solar radiation continuously blowing away slowly, and then to the space, and then slowly this atmosphere reduces in the Mars system. And this is a kind of expression, of course. Now I mean, if we can have a Mars system something like this, like a right hand side, so it is going to be really interest for us, and it is really important, and we are very pleased to see this kind of Mars someday even. But this is they believe that the Mars, how does it look like 3 billion years ago? We don't know exactly, but kind of an impression. Now today is completely dry off. So this is a time scale about where the atmosphere actually get lost, and then completely dry off the water available on the surface. And then I will show you some missions, right? Now what's going on in there. This is an InSight mission. This was actually launched 2018, May 2018, and reached November 2018, the same year, 26 November. This was actually not a rover. This is a lander, and landed and then start doing some experiment. Especially this is designed to investigate the geological events like even just measure the geological properties of Mars, like temperature using this heat flow probe and this seismic instrument to measure especially the seismic activities on Mars. So then the results actually give some sort of ideas like up to now 174 Mars quakes, like not earthquakes, Mars quakes, but they are not very strong. They are 24 of them are like 3 to 4 magnitude scale. These quakes last for 10 to 20 minutes. Actually, the the time is more than the earthquakes, right? So the time is, but they are very weak ones, but time lap is very big, like 10 to 20 minutes. Seismic waves pass more easily in Mars, so they have found this information with this Mars Insight mission. So this is a very interesting picture, the landslide, right? The landslide of happened on Mars, taken from an orbiter. Okay, this is the explanation for that, why the Mars actually got kind of a very higher mountains in the solar system. The explanation is Earth has, we have very special geological activity called plate tectonics. Plate tectonics. So when this lava actually reached the surface from these holes, right? Then that is the way to form the mountains, right? So just actually get into that and the bottom side, and then getting, and the lava comes out completely, and then it just heaping over here, and then increase the mountain range, the just forming the mountains. But plate tectonics move this the surface crust, so shift it there, and therefore it will move the mountain range, and then the new mountain will form. So the amount of mountains actually form is more, but there's no way of actually getting higher mountains with these plate tectonics. Rather in Mars, it's different. There's no plate tectonics going on. And whatever the lava comes out from this hole, it's coming from the same hole and then getting on the top of that and just filling over top. And then what happens? Get the very high mountains. So this is a very interesting geological difference in Mars and Earth system. So then this is called the Gale crater. It's actually formed by a huge impact, right? Very much earlier, just 96 miles across, Gale crater. It's a very interesting place. Actually, all the missions are looking at it, this crater. And this Gale crater also has its sedimentary rocks and all these things. You can see the images. The sedimentary rocks also form, because once the crater forms, it will fill. It might actually fill with the water, and these sedimentary deposits were there for a long time, and then form this kind of geological features that today we can see. So recently they found that the methane source, this temporary increase in methane sharply up and then back down tells us that there might be some relative localized source, Curiosity rover, since then. Actually, this was found by the Curiosity rover. The localized source should be there. These methane content actually just getting higher and lower. They found it with this Curiosity mission. And still, these teams actually could not discover what is the source of this methane. So these are maybe a possible source of biological. So it's very interesting if it is biological. If you know that the methane produced by the Earth system is basically, mainly it's a biological process, right? But even non-biological process can produce the methane also. So people who knows about chemistry very much, they can explain these things very nicely, but I am not very much familiar with these things, right? So you can find out more details on this. This is the next rover, Mars 2020 rover. It's on the way right now. February 18th is going to land it. Maybe it's worth to see how they are going to celebrate the landing, successful landing. So this is going on, and this is called Perseverance rover. The name given, Perseverance. I just put this image. Now the Americans, the NASA and all these agencies do something very interesting programs. This name was given to this rover by this kid, 13-year-old kid, right? They have actually give the like a contest, right? Just to propose a name for the next Mars rover. So throughout the US, they just posted this one. So please propose a name for our rover, and they have selected this name. This is given by a 13-year-old boy in Virginia. So why the NASA, those agencies doing like such a program? Because they realize that one thing is they do these missions. They actually spend billions of dollars, right, for these missions. And sometimes people think about that. Even in Sri Lanka also, we know that I mean, people, when they are actually investing money for science, very much, research very much, right? It's very difficult to convince them. Why? Because there's no, I mean, direct impact on the society, and sometimes the money has actually wasted, and the mission actually failed, and the money has wasted, right? So they will argue in that way. So the same thing actually slowly, I mean, going on in the other countries as well. They spend a lot of money. This money actually came from the taxpayers. So they wanted to show that everybody has contributed to these missions. So then they launch this kind of programs, right? So as a result of that, all these missions now, right now in the future, they have some way take the contribution from the society, right? So it's a good sign of to start it in such a way like that. So this is launching the 30th July 2020 and 18th February 2021. Very soon will land. The purpose of this rover is investigation of the present rover is robotic. This is a very heavy rover. It's like a similar to that similar big car size rover, more than 1,000 kg weight. The rover's astrobiology mission will search for a sign of past or microbial life. This is the main purpose of this mission, to find out any clue, any sign of a microbial or bacterial type of life. It will characterize the planet climate and the geology, collect sample of for return, a future return to the Earth, and pave the way of the human exploration of the red planet. So it will take a sample and keep it for the next mission, and going to take it to the Earth and do the research, do the investigation on Earth. So these programs going on right now, I just posted these programs only just to give some idea. Maybe you all might actually get some interest about these things to find out later on, and then just go beyond this and find out more information later on, right? So this is one experiment it's going on here in Mars. It's not actually going on Mars, still it's doing some research on that, how to produce oxygen from carbon dioxide, right, for future missions. Because now to go to the Mars, it will take 6 months, right? And it's a huge amount of fuel, as well as the supply, food, and all these oxygens have to carry with the spaceship. And there are a lot of space needed for this. Then for the coming back, if it is actually planned for the coming back mission, right? So the supply is doubled. The supply should be doubled. So therefore, they thought about to produce oxygen on Mars, and then refueling from there, and then coming back, right? So these kind of investigations going on. Now, this is another interesting mission, Mars One mission. Mars One mission. If you look at these websites are there, Mars One mission. These missions actually designed to get the society involved with this Mars exploration, right? More and more, right? Get involved very much, the society. Basically, the society means everybody. Especially, they are focusing on young generation, not us, maybe not you even, right? But very much young generation, like maybe a 5-year-old kid or maybe 10-year-old kid, right? Why? Because in the next 20 or 30 years, those are the people, or those are the ones actually just exactly going to the Mars. right, as engineers, scientists, because they have to send the crew first, the team, like to build the supporting system, the make all the supporting system on Mars. So a lot of research has to be done, a lot of groundwork has to be done. So therefore, then they have to send these engineers and scientists, but it is not going to be easy. Why? If I ask today like this, do you like to go to Mars, even though like you are engineer, like a scientist or something? Do you like to go to Mars and then for any like a task to do and then come back, or sometimes not come back, and maybe you stay there for a long time? Are you willing to go there? No, most of the people, most of you are not willing to go, because one thing is we have to spend six months in the space flight. 6 months, you can't imagine that how you are actually going to stay in this corona time, right, in your room or in your house. So can you imagine that you're stuck in a spaceship for 6 months, just eating like a small amount of food and nothing, no entertainment and nothing going on. So it is very difficult to keep your mindset, to get them ready to go to Mars and work over there. So they knew that. So it is not going to be easy task. It's very difficult to make your mind to prepare to go there. So what they do is they just give the idea to the young generation. Okay. So this Mars One mission is very interesting. Everybody can actually join this mission. Everybody can register to this website and then just get involved with what they are doing, the work, like simple stuff, right? Mars exploration, basically information sharing and all. So what they are doing is they just prepare some sort of a team, a set of people, so who is actually willing to go there someday. So that's what they do. So here, these experiments, this is Earth, right? This is not Mars, this is Earth. So they pretend that they are actually landed on Mars and they do some research on Mars, just wearing these suits, and then all these the supporting life supporting systems wearing and all these things. They do these things in Earth system. So they just try to make the mindset, right, to go there and then live for a long time, and then otherwise we can't do this and we can't achieve this target, right, to change this world to some sort of a friendly place. So this is a very good program, that is a popularization program, outreach program, public outreach, just produced with the InSight mission. InSight mission already landed over there. So they issued a boarding pass, right? If you like to go with the InSight mission, then they issue a boarding pass for those who like to go there. So then I also registered with my entire family. You can see my name, my wife, my 2 kids. I just got the 4 boarding pass for that. And then they put our names on a chip in that mission. So the virtually you go there, right? The virtually you travel to Mars, and that chip was there with the mission. And someday, if some people actually just landed on Mars, then they recovered, and then they can actually retrieve the names over there. So it's virtually, we feel that we go to Mars, right? It's a very interesting activity, kind of outreach program. So these kind of programs are going on. So there are 2.4 million names are going with the Mars with the InSight mission. So with this, I will conclude my presentation, of course, a little bit longer, but I just want to give some impression about that, what's going on right now, what are the ways people are looking at it. Maybe you can actually, we don't know exactly, maybe you might be another person which is actually involving in Mars exploration in next generation, right? So it's very interesting to get involved with these programs very much. Okay, thank you very much just for listening, and I will answer questions if possible from my knowledge, whatever I have.
Yes, sir. Thank you, sir. I know everyone will agree that the lecture was very informative, well structured, and it was presented in a way so all of us could understand. Now let's move into our Q&A session. Here our students can ask any questions regarding the lecture or the relevant subject area. Please feel free to ask any question by unmuting the mic or drop a message in the chat box and sir will answer for them. I encourage you all to take this valuable opportunity and ask questions. But at first, our lecturers might have a few questions. Sir, madam, the chance is for you.
Yes, it is a very interesting talk, Mr. Janaka.
Thank you.
And one question I have is that if any exploration has collected any soil from the Mars surface, and what is the composition of that?
Yes, actually, at the moment we don't have any sample from Mars, so that is going to be, so that Mars 2020 rover has that the preparations. So it is actually taking a kind of a container just to get the sample, but as far as I know that it is not just returning with the same mission, because there is no way of returning with that mission. So I think that the container will keep it for some time in that the place where in the Mars. The future mission actually they will design to take that sample. So that is the plan at the moment. So we don't have at the moment any sample from Mars. But there are some in situ measurements like those rovers, especially Curiosity, and those rovers has the instruments like spectroscopic measurements, maybe some other instruments also to check whether the composition of the Mars surface, the soil basically. They are going on in situ, but the present the most newest actually mission, Mars 2020 rover, is the one they designed to get the sample to the Earth.
Okay.
Yeah.
Okay. Thank you. Thank you.
Any more questions from lecturers? If it, so, students and other parties who are here today, present here today, you can ask questions from our speaker.
Hello, sir.
Yes, yes.
So I have a small question.
Uh-huh.
So you mentioned that there are the rovers have found some ice inside the surface of Mars, water ice.
Not on the surface, basically.
Inside the surface,
Inside, yes,
beneath the surface.
Yeah.
If so, how much of ice are we talking about? Is it like, can we recover the oceans that was found 3 billion years ago on Mars? If that ice is melted, is it just a trace amount, or is there like lot of ice, water ice found on Mars? Can we expect to make it water someday and like somehow think of getting the oceans back, or is it just a small amount of water we are talking about?
No. Actually, it is a small amount of water. We cannot actually think about to get back the ocean conditions like that, similar. It is, I think, a small amount of water. Like I think that the picture exactly say that is maybe a few square kilometers, right? The water layer, just like a lake or something like that. The thickness is very small. That cannot actually just get into any kind of usage. Maybe I cannot actually just imagine that what is the usage of that amount of water. But however, the important thing, they have found some liquid water. We cannot think about to use it for our future missions or something like that. But the water means the importance is that not to get use it that, but whether the water has some sort of a life, right? The liquid water means a very high potential, a high possibility of having some sort of a life over there. That is what we are looking for right now. Even that Mars 20 rover mission also actually planned to look at least some sort of a microbial life, whether it is existing on the Mars system. So if there's a water means there's a high potential to have some sort of a primitive life form. That is the idea. Okay.
Right, sir. Thank you so much.
Sir, some questions are there in the chat box. You can check.
Okay, sure. I can't actually scroll over it, so it doesn't come out. The top. Okay, sure, sure. I have it. Yes, sir. Yeah, the first question, sir. Why do the Mars rover move so hu- courteously? Uh, it's courteously, right? So why do the Mars rovers move so courteously? You mean the slower? You mean, right? Uh, uh, I think it is. Uh, it is something like these rovers are designed for a very slow movement, like even the just using the lowest power, right? So they are operating with the minimum power because the power is very important for these rovers. These are actually powered by solar cells. So the solar cells, the battery is actually charged by the solar cells, and if you not get right amount of sun solar radiation in a particular time, then you won't be able to run the rover. So therefore, these especially these missions actually designed to run or operate with the minimum power. So maybe even to roll over the rover, they need the motors just going on continuously. The motors actually use the most of the power, electricity. So therefore, they are slowly moving, as well as these movements just to make sure that use the minimum power consumption. All these instruments are actually designing to consume the minimum power, right? So that's why these are challenging tasks, right? I mean, how we have to improve the technology for those kind of thing to run over a long time a mission. Even there's no light on the surface of Mars, they can actually withstand without dying, because the same thing happened for the Opportunity rover. If it is covered by several months completely, then you won't be able to recover it, because the battery ran off, and battery do not actually charge it the right time with the lowest power. So then you can't actually recover. So they have to take care of all these challenges when they design it. So they just plan it for such a movements, like a very slow movements and minimum power consumption and all. I hope I answer your question. Sir, in an interview, Elon Musk said that if increase the temperature on Mars, we can drop nuclear weapons on both poles. What is science behind that? Uh, increase the temperature on Mars, we can drop nuclear weapons on both poles. I think that people never think about to put just do the pollution what we did on the planet Earth, right? The radiation pollution. You know that we are having some bad experience of polluting uh, radiation pollutions, right, in the Earth system. So people, that now the countries understand, like the European countries, they completely eliminate their nuclear power stations right now. Completely, Germany has gone for the green power, so they completely eliminate the nuclear reactors. So therefore, people are now thinking about in that way. Of course, there are some countries still very strongly in the power and the nuclear power, depending on the nuclear power. But I don't think that the space exploration just go with the nuclear kind of a nuclear power or nuclear disaster, or just get dirty about that. Get dirty means those places. Uh, uh, I mean, still nobody has touched it, and so then the people are getting involved with that, and then we are going to pollute those areas also. I mean, in that way, it is not ethical to think about to do some nuclear explosion on Mars at the first place, and the radiation comes out. Then how are you going to live with that, right? So that is not a good practice. About, I mean, personally, I believe it is not a good practice about to do some nuclear explosion to raise the temperature on Mars system. We can, I think, still we can think about some other technology, how do you increase the temperature, global temperature. So what would happen if Olympus Mons erupted? Does it have ability to destroy Mars? Now these volcanoes, now they are inactive. Mostly they are inactive. Don't see any activity right now on Mars system. The Mars is also not geologically very active planet right now, but earlier might be a very active planet, but now at the moment it is a geologically inactive planet. All these volcanoes are now dead, completely dead. No eruptions occurred, right? So there's no way of, I think, erupting right now. So they haven't had any evidence of the recent eruptions of these volcanoes. So what would happen if the Olympus Mons erupted? Does it have? Okay, so you mentioned that the Mars is at the outer edge of the habitable zone. On the polar side, I assume, is it possible that once many years ago Mars was in the middle of the habitable zone, where it is a condition to actually sustain life? Is it possible that once many years ago? But the Mars actually cannot stay. It is always at the same place. Once the solar system actually forms, it is at the same place, right? It was not actually shifted later on. Shifted means the very early solar system might be completely a different solar system, right? Before all the planets actually completely differently formed, right? But once they actually form it precisely, and they decided their orbits and all these things, the Mars is at the same point. So Mars is not actually just deviate or just shifted from the one place to another place during that time. I believe, right? That's what I believe. I think it's true. So it is always there in the edge of the habitable zone. It was not in the middle of the habitable zone. But if it is actually little closer to the closer to the Earth than this, so maybe the conditions might be different, right? Maybe this condition, the present condition of the Mars system would have been different, like maybe a little bit higher temperature, average temperature might be a mild, like maybe close to 0 degrees at least. So then it can be a kind of a different condition. But now it is always there with no change. So if there's a possibility of colonizing Mars, how can we avoid getting struck by meteors and asteroids? That's a good question. Those are the challenges when you are going to live over there. How do you are going to survive with this thin atmosphere? There's a radiation. Even we don't think about the meteors and asteroids. You can't go out in the Mars atmosphere, because it is completely exposed to the very high radiation. you can't actually escape from that radiation even with the suits as well. I mean, you can actually protect it to some extent, right, with the suits, radiation suits. But you know that you have to work out. I mean, if you're going to live over there, you have to stay outside the mass, the surface. Then if you stay for maybe 6 to 8 hours in the Mars system, then even those suits cannot actually protect you. Even some of the radiation can expose can penetrate through this and then get into your body. So those are the challenges. Still, you can actually think about to go stay there underneath. That means you can build some sort of a laboratories or something like that. That I heard it earlier. What they planned it, they put the laboratories underground. So then at least you are protected, right? So otherwise, you are not exactly protected. Exactly what happens? All these meteorites actually hit the surface, right? And then you can't actually escape from those meteorites as well. There's no one actually, no system can prevent you from the meteorite showers. Yeah. So that's why it is still, even there are some similarities, still it is not going to be easy. We cannot think about it even, right? So we are very far from that, the colonization or habitability conditions, right? We are very far still. It will go a long way. Okay, I think so. That's all the questions posted here.
Okay. So there is another one.
Okay, another one comes. Okay.
Yeah.
Where's that? The last one is that, is it?
What are the places on the Earth that have similar condition to Mars?
What are the places on the Earth that have similar conditions to Mars? So those places I showed you, especially these the deserts areas, like what I showed you, that is a part of a Libyan desert. Basically, sometimes the soil content is different, right? The soil content is completely different from the Mars and Earth, but the appearance is going to be same appearance, right? Otherwise, they are different. But basically, the desert areas, like in Earth system, it is some way similar to the Mars system. Maybe appearance, right? Not the content even. The content might be different. It's a very iron-rich content, and still people actually investigating what are the elements are there, or the compounds are there in the soil, right?
Sir, I have a small question for you.
Yes, yes.
Before 3 million years ago, water was there on Mars, right?
Yes.
So at the moment, the composition of the atmosphere should be suitable for the existence of water, right? How did it change to other composition that evaporations started up and
at the present condition, that is a completely a carbon dioxide. Now there's no, there's no way. Now, if there's a water, now let's assume that there's a water right now, so that won't be a much effect from the atmosphere, right? Atmospheric conditions are, but the thing is, even let's say you just put some water, it's impossible, but if you put some water on the Mars system, even the Mars atmosphere could not reserve it, could not preserve it, right? Because the same thing going to go then start happening, right? The same thing means the thin atmosphere, atmospheric pressure is very low, right? And then the boiling point is still very low, and then start evaporating because of the solar radiation. So the atmospheric content and the atmospheric, the size of the atmosphere is not really favorable to sustain the water or to keep the water on the surface. Even if you try to put the water, produce the water on and just to put it over there, it won't be there. So I think this is my guess. I don't know. Maybe I might be wrong, right? So the best thing is how do you going to increase them? How do you going to increase the atmosphere, thickness of the atmosphere, right? So if we can actually increase the atmosphere, the thickness of the atmosphere, so we can have some sort of an idea that then other maybe the water or maybe something can actually support it with that, and then keep on going that and then growing it without. Otherwise, even though the some water is there, so it will disappear again with a very thin atmosphere.
Okay, thank you, sir. I think there are no any more questions. So time is also running up. Thank you so much, sir, for the valuable insight you gave us. Now I would like to call upon the Secretary of the Astronomical Society, Mr. Udita Jayatilaka, to deliver the vote of thanks. Udita, the platform is for you now.
Yes, can you all hear me?
Yes, Udita.
Yes, so it's my pleasure to actually deliver the word of thanks for this entertaining lecture. And first of all, I would like to thank our guest speaker, Mr. Janaka Adassuriya. Thank you very much, sir, for joining with us today and for spending your valuable time with us. And none of this would have been possible without you. So thank you very much. And next, I would like to thank the head of the Department of Physics, Dr. V. Sivakumar, and the Senior Treasurer of the Astronomical Society, Dr. T.P. Ranavaka, for their help, support, and for always encouraging us to conduct these kind of events. So thank you, sir. And then I would like to thank all the lecturers and the temporal staff members for your presence here. As a society of the Department of Physics, your presence means a lot to us, so thank you. And next, I would like to thank the President of the Astronomical Society, Mr. D.A.B. Abekon, and all the members of the society for making this event a grand success. And last but not least, I would like to thank all of you who joined with us today to enjoy this amazing lecture with us. And yeah, with that, I'll conclude my word of thanks and thank you.
Okay, thank you.
Okay, thank you, Udita. Well, we have reached the end of our event. Again, thank you everyone for your presence here. Also, please note that the recording of this event will be uploaded into our YouTube channel of the Astronomical Society of University Peradeniya. So if you gain something, make sure to pass the message so others can get same from the opportunity. So let's wrap it up. Wish you a good day and thank you. Good night.